What if the answer to humanity's oldest question, are we alone in the universe, didn't come from us at all? Instead, it might come from artificial intelligence. Think about it. While we've been scanning the skies for decades, searching for signs of life beyond Earth, AI could be the game changer we didn't see coming. With its ability to process vast amounts of data, detect patterns we might miss, and even decode languages we've never heard, AI might just become the first to uncover the secrets of extraterrestrial life. This isn't science fiction, it's a real, unfolding possibility. Today, we're diving into how AI could revolutionize the search for alien life, exploring everything from analyzing cosmic signals to tackling questions we haven't even thought to ask yet. By the end of this video, you'll see why the ultimate discovery might not be made by humans, but by the machines we've built. Let's get started. Humans have always been the pioneers of space exploration, from the first steps on the Moon to the rovers traversing Mars. But let's face it, our biological framework has its limits. We can only process a finite amount of information at a time, and our ability to explore distant worlds is restricted by the sheer scale of the universe. The distances are vast, the environments are harsh, and the resources required to sustain human life in space are immense. Even our most advanced telescopes and probes are only scratching the surface of what's out there. Enter artificial intelligence. Unlike us, AI doesn't need oxygen, food, or sleep. It can sift through terabytes of data in seconds, spotting patterns and anomalies that might take humans years or even lifetimes to uncover. Imagine a system that can analyze radio signals from distant stars, identify potential biosignatures on exoplanets, or even navigate treacherous terrains on alien worlds without risking human lives. AI's ability to work tirelessly and process complex information at incredible speeds could make it a game changer in the search for extraterrestrial life. But it's not just about speed and efficiency. AI can also venture into places too dangerous or inhospitable for humans. Think about the extreme conditions on Europa, Jupiter's icy moon, or the crushing pressures on the surface of Venus. Sending humans to these locations is fraught with risk, but an AI-powered probe could explore them without hesitation, gathering data and sending it back to Earth for analysis. This raises a fascinating possibility. Could AI detect signs of life in places we've never even considered? While humans bring intuition, creativity, and the ability to make leaps of logic, AI offers precision, endurance, and the capacity to handle overwhelming amounts of information. Together, these strengths could complement each other in the quest to answer one of humanity's oldest questions. Are we alone in the universe? But as we look to the future, it's worth asking whether AI might one day surpass us in this search, not because it's smarter, but because it's unbound by the limitations of biology. When it comes to searching for signs of life beyond Earth, the cosmos is brimming with possibilities and an overwhelming amount of data. Enter artificial intelligence, a tool uniquely suited to tackle this colossal challenge. One of the most exciting frontiers for AI in astrobiology is its ability to analyze cosmic signals. Think about it. The universe is filled with radio waves, light patterns, and other electromagnetic signals. For humans, processing this sheer volume of information would be impossible. But AI thrives in this environment, tirelessly sifting through data in ways we simply can't. Machine learning algorithms trained to recognize patterns can identify anomalies that might hint at extraterrestrial intelligence. These anomalies could be anything from a repeating radio signal to an unusual light pattern that doesn't align with natural cosmic phenomena. What makes AI particularly powerful is its precision. Unlike humans, AI doesn't get fatigued or distracted. It doesn't overlook subtle details or dismiss something as insignificant. It's designed to notice the unusual, even in the vast noise of space. Consider this: over the years, humans have detected intriguing signals like the famous WOW signal in 1977, which sparked speculation about extraterrestrial origins. Yet, we've never been able to confirm their source. AI could change that. By analyzing historical data with fresh algorithms, it might uncover patterns we missed. More importantly, AI could monitor the skies in real time, catching faint signals that would otherwise slip through the cracks. The question isn't just whether AI can detect these signals, it's whether it can do so faster and more reliably than we ever could. Machine learning is already transforming signal detection in other fields, like medicine and finance, where it identifies patterns invisible to the human eye. Applying this same technology to the cosmos opens up a world of possibilities. For instance, AI could flag signals that deviate from known astronomical phenomena, potentially pointing to artificial sources. It could also help filter out interference from human-made signals, ensuring that what we're detecting truly comes from the stars. The implications are profound. If AI detects a signal that suggests intelligent life, it could reshape our understanding of the universe and our place within it. But even if it doesn't, the sheer efficiency of AI in processing cosmic data accelerates our search, bringing us closer to answering one of humanity's oldest questions: are we alone? For decades, the search for extraterrestrial intelligence, or SETI, has been at the forefront of humanity's quest to answer one of our most profound questions: are we alone in the universe? But in recent years, this pioneering effort has taken a groundbreaking leap forward by integrating artificial intelligence into its mission. The collaboration between SETI and AI isn't just a technological upgrade, it's a transformative partnership that's reshaping how we search for signs of life beyond Earth. At the heart of this collaboration is the challenge of sifting through an overwhelming amount of data. Imagine the cosmos as a vast ocean of signals, radio waves, light patterns, and other forms of cosmic communication. Hidden within this noise could be the faint whispers of an extraterrestrial civilization. The problem is, human scientists alone can't process all this information. That's where AI steps in. By training machine learning algorithms to detect patterns and anomalies, SETI has been able to analyze data on a scale that was once unimaginable. One of the most exciting projects in this space involves using neural networks to identify potential alien signals from radio telescope data. These AI systems are trained to distinguish between natural cosmic phenomena, like pulsars or distant galaxies, and signals that might be artificial in origin. It's like teaching a computer to recognize a needle in a haystack, except the haystack is the size of the universe. But here's the fascinating part: AI doesn't work in isolation. It's a tool that amplifies human expertise. Scientists at SETI use AI to narrow down the possibilities, but it's still up to humans to interpret the results and determine whether a signal could truly be evidence of extraterrestrial intelligence. This synergy between human intuition and machine precision is what makes the collaboration so powerful. Take, for example, the Breakthrough Listen initiative, a massive project that's scanning millions of stars and galaxies for signs of life. By employing AI to process the flood of data from this initiative, researchers have been able to identify intriguing signals that might have otherwise gone unnoticed. While none of these signals have yet been confirmed as alien in origin, each one brings us a step closer to answering the ultimate question. What makes this partnership even more remarkable is its potential for discovery. AI isn't just speeding up the search, it's opening up new possibilities. By analyzing data in ways that humans couldn't, it might uncover patterns or signals that we didn't even know to look for. In a sense, AI is expanding our cosmic horizons, helping us see the universe in a whole new light. So, as SETI continues its mission, one thing is clear: The fusion of human curiosity and artificial intelligence is transforming the search for extraterrestrial life. It's a reminder that sometimes the most profound discoveries come not from choosing between human and machine, but from bringing them together in pursuit of a shared goal. As we venture deeper into the cosmos, artificial intelligence isn't just listening for signals, it's also scanning for signs of life itself. Biosignatures, those chemical or physical indicators that hint at the presence of living organisms, are like fingerprints left behind by extraterrestrial life. From the gases in a planet's atmosphere to the way its surface reflects light, these subtle clues could be the key to unlocking one of humanity's greatest mysteries. And here's where AI steps into the spotlight. Unlike traditional methods that rely on human analysis, AI can sift through vast amounts of data with incredible speed and precision, picking up patterns that might otherwise go unnoticed. Imagine an exoplanet thousands of light years away, its atmosphere rich with methane or oxygen gases often associated with biological processes. AI tools trained on Earth's own biosignatures can analyze these compositions to determine whether a planet might be hospitable to life. One striking example is the use of machine learning to interpret spectra, the unique light signatures emitted or absorbed by a planet's atmosphere. By comparing these patterns to known biosignatures, AI can flag potential candidates for further study. But it doesn't stop there. Surface features like the presence of liquid water or unusual geological formations can also be detected and analyzed. Scientists are already using AI to map the surfaces of distant worlds, searching for regions that might support life as we know it, or even life we've yet to imagine. The question then becomes, could AI identify a biosignature on an exoplanet before humans even know it's there? With its ability to process data at an unprecedented scale, the answer might just be yes. This isn't just about finding life. It's about redefining how we search for it and perhaps discovering that we're not alone in the universe sooner than we ever thought possible. So, we've talked about how AI could detect extraterrestrial life, but what happens after that? Imagine we receive a signal or a message from another world. Detecting it is just the first step. The real challenge lies in figuring out what it means. Alien communication might not resemble anything we've ever encountered. It could be based on mathematics, symbols, or even concepts we can't yet grasp. This is where AI's ability to process and analyze complex patterns comes into play. It could sift through the data, identify potential structures, and even attempt to decode the message. But here's the catch: interpreting alien communication isn't as straightforward as translating between human languages. AI would need to work with information that's entirely alien, literally. It would have to navigate cultural, biological, and cognitive differences that could make the message unintelligible to us. For example, what if their way of thinking is so different that even their logic doesn't align with ours? AI's success would depend on its ability to adapt to these unknowns, learning from the data in ways that might challenge its own programming. And then there's the question of accuracy. How do we know if AI's interpretation is correct? Without any existing framework to verify the translation, we'd be relying on algorithms to make educated guesses. This raises concerns about potential misunderstandings. What if a friendly message is misinterpreted as a threat, or vice versa? The stakes are incredibly high, especially when dealing with the unknown. Despite these challenges, the potential is thrilling. AI could act as a bridge between civilizations, helping us decode messages that might otherwise remain a mystery. Its ability to process vast amounts of data quickly and identify patterns invisible to the human eye gives us a unique advantage. But it's also a reminder of how much we still have to learn about the universe and ourselves. Could AI become the ultimate cosmic translator, or will the complexities of alien communication prove too much even for advanced technology? The answer might lie somewhere in between as we continue to push the boundaries of what's possible. Picture this, a telescope floating millions of miles from Earth, scanning the cosmos with precision and speed far beyond human capability. This isn't science fiction, it's the reality of today's AI-powered telescopes and space probes. Instruments like the James Webb Space Telescope and autonomous rovers such as those exploring Mars are now equipped with artificial intelligence, giving them unprecedented abilities to process data, make decisions, and even identify potential discoveries in real time. But here's the kicker. Could these AI-driven tools be the first to detect signs of extraterrestrial life, spotting something we might miss entirely? The integration of AI into space exploration is nothing short of transformative. Take the James Webb Space Telescope, for example. Its AI algorithms sift through massive amounts of data, identifying patterns and anomalies that might indicate distant planets, atmospheres, or even biosignatures, hints of life. Without AI, this process could take years of manual analysis, but with it, discoveries are happening at a pace we've never seen before. And it's not just about speed, it's about accuracy. AI can detect subtle changes in light or chemical compositions that the human eye might overlook, opening up possibilities for finding life in places we've never considered. Then there are autonomous rovers like those exploring the surface of Mars. These machines are no longer just following pre-programmed instructions. Thanks to AI, they can navigate rough terrain, avoid obstacles, and even choose which rocks or soil samples to analyze based on their potential scientific value. It's like having a geologist on another planet making decisions on the fly. And while these rovers are looking for signs of ancient microbial life, the same technology could one day be used to detect more advanced forms of life, whether on Mars, Europa, or even distant exoplanets. But the real game changer lies in the ability of AI to process vast amounts of data from multiple sources simultaneously. Imagine a network of telescopes and probes working together, sharing information in real time and cross-referencing their findings. If one instrument detects an unusual signal, a burst of radio waves, a flicker of light, or a chemical anomaly, AI could instantly analyze whether it's worth further investigation or if it's just cosmic noise. This collaborative approach could drastically shorten the time it takes to identify potential signs of extraterrestrial life, giving us a head start we've never had before. So, could an AI-powered telescope spot an alien civilization before we even notice? It's not just possible, it's becoming increasingly likely. As AI continues to evolve, it's not just enhancing our tools, it's reshaping the way we explore the universe, pushing the boundaries of what we thought was possible, and bringing us closer than ever to answering one of humanity's greatest questions: are we alone? Neural networks are like the detectives of artificial intelligence, trained to spot patterns and solve mysteries hidden within vast amounts of data. In the realm of astrobiology, where the data can be as vast and complex as the cosmos itself, these systems shine. But what makes them so uniquely suited for this task? At their core, neural networks mimic the way our own brains process information. They consist of interconnected layers of artificial neurons that learn to recognize patterns by analyzing examples. In the search for extraterrestrial life, this means they can sift through an overwhelming amount of data, from spectral signals to atmospheric compositions, and identify subtle anomalies that might hint at biological activity. For instance, when analyzing the chemical makeup of a distant exoplanet's atmosphere, a neural network can pinpoint unusual combinations of gases such as methane and oxygen, which on Earth are often produced by living organisms. One of the most exciting applications of neural networks in astrobiology is their ability to process information from telescopes and space probes. Take the James Webb Space Telescope, for example. It captures an extraordinary amount of data, far more than human scientists could analyze in a lifetime. Neural networks can step in, scanning this data for patterns that might indicate habitable conditions or even biosignatures, chemical signs of life. But it's not just about speed and efficiency. Neural networks excel at uncovering patterns that might be invisible to human eyes. For instance, they can detect faint, irregular signals in radio waves that could suggest extraterrestrial communication. They can also analyze geological features on planets like Mars, identifying formations that may have been shaped by ancient microbial life. What makes neural networks truly groundbreaking is their adaptability. Unlike traditional algorithms which rely on predefined rules, neural networks learn and improve over time. The more data they process, the better they become at recognizing potential signs of life. This self-improving capability makes them indispensable tools in the ongoing quest to answer one of humanity's oldest questions: are we alone in the universe? By harnessing the power of neural networks, scientists are not just speeding up their search, they're fundamentally transforming the way we explore the cosmos. These systems are opening doors to discoveries that might have remained hidden, bringing us closer than ever to finding evidence of life beyond Earth. What if we could predict where alien life might thrive before we even point our telescopes? Artificial intelligence isn't just about reacting to data, it's about forecasting possibilities. By sifting through massive amounts of information from known exoplanets and simulating countless environmental scenarios, AI can pinpoint the most promising candidates for harboring life. Imagine a system that can analyze atmospheric compositions, surface temperatures, and even the potential for liquid water, all in a fraction of the time it would take humans. This isn't science fiction, it's happening right now. Researchers are using predictive modeling to narrow down the search for Earth-like planets, turning what was once a needle in a haystack challenge into a targeted mission. By identifying patterns and extrapolating from what we know about life-supporting conditions here on Earth, AI is essentially helping us draft a cosmic roadmap to the stars. The implications are staggering. Instead of randomly scanning the skies, we could focus our efforts on worlds that show the most promise, saving time, resources, and perhaps even accelerating one of humanity's greatest quests, finding life beyond our planet. Could AI lead us to the next Earth-like world? With every calculation and simulation, it's bringing us one step closer. The moment an AI system detects signs of extraterrestrial life, it won't just be a scientific milestone, it will spark a whirlwind of ethical questions. Who gets to claim ownership of that knowledge? Is it the organization that built the AI, the government funding the project, or perhaps humanity as a whole? This isn't just about scientific bragging rights, it's about the immense power and responsibility that comes with such a discovery. Machines, by their nature, don't have a sense of ethics. They analyze data, identify patterns, and deliver results. But when those results could reshape our understanding of life itself, the implications stretch far beyond algorithms. Think about it. If an AI uncovers evidence of extraterrestrial life, how do we ensure that this discovery is shared responsibly? Would there be a risk of suppressing the information for political or economic gain? Or could it lead to widespread panic if not communicated thoughtfully? These aren't abstract concerns, they're real challenges that could emerge the moment such a discovery is made. And then there's the question of bias. AI systems are only as good as the data they're trained on. If the training data reflects human prejudices or limitations, could that skew the interpretation of alien signals? On a deeper level, what does it mean for humanity if a machine makes the first contact? For centuries, the search for extraterrestrial life has been a deeply human endeavor, driven by curiosity, wonder, and a desire to understand our place in the universe. If AI takes that step for us, does it diminish the significance of the discovery? Or does it open up new possibilities for collaboration between humans and machines in exploring the cosmos? These questions don't have easy answers, but they're essential to grapple with as we move closer to a future where AI plays a central role in astrobiology. The ethical implications are vast, touching on everything from intellectual property to global cooperation. And as we continue to integrate AI into the search for extraterrestrial life, it's crucial that we approach these challenges with thoughtful deliberation, ensuring that the pursuit of knowledge remains a force for good. When we think about extraterrestrial life, our minds often jump to visions of intelligent civilizations, advanced beings with technology far beyond our own. But the truth is, the first signs of life beyond Earth are far more likely to be microscopic. Microbes, tiny organisms that thrive in extreme environments, could be the key to unlocking one of humanity's greatest mysteries. And here's where artificial intelligence steps in. With its ability to process vast amounts of data at incredible speeds, AI is becoming an indispensable tool in the search for microbial life in our own solar system. Take Mars, for example. Rovers like Curiosity and Perseverance have been collecting soil and rock samples, searching for clues that might hint at past or present microbial activity. But analyzing this data manually is a monumental task. AI can sift through the information, identifying patterns or anomalies that might indicate the presence of microbial organisms. It's like having a detective who never tires, constantly scanning for the tiniest hints of life. Then there's Europa, Jupiter's icy moon, and Enceladus, Saturn's geyser-spewing satellite. Both are believed to have subsurface oceans that could harbor microbial life. Future missions to these moons might deploy AI-powered instruments to analyze ice samples or plumes of water vapor ejected into space. AI could detect chemical signatures or biological markers that would be nearly impossible for humans to spot on their own. It's a race against time and distance, with AI acting as our eyes and ears in these distant, inhospitable worlds. The question isn't just whether AI can find microbial life, it's whether it can do so before humans do. With its speed and precision, AI has the potential to make groundbreaking discoveries long before we're able to send astronauts to these locations. It's a fascinating thought. Machines designed by humans might be the first to uncover evidence that we're not alone in the universe. And while that might not involve little green men or intergalactic empires, the discovery of even the tiniest microbes would reshape our understanding of life itself. Imagine a computer so powerful that it could solve problems in seconds which would take traditional machines thousands of years. That's the promise of quantum computing, a technology that could transform not just our understanding of the universe, but also how we search for life beyond Earth. Quantum computing operates on principles entirely different from classical computers, leveraging quantum bits or qubits, which can exist in multiple states simultaneously. This allows quantum systems to process vast amounts of data and perform complex calculations at mind-bending speeds. When paired with artificial intelligence, it opens up entirely new frontiers in astrobiology. One of the biggest challenges in the search for extraterrestrial life is the sheer volume of data we need to analyze. Telescopes like James Webb and radio observatories like SETI collect enormous datasets, searching for faint signals or patterns that could hint at life. Traditional AI systems are already helping sift through this information, but quantum AI could take this effort to an entirely new level. By processing multiple possibilities at once, quantum computers could identify subtle patterns in data that might otherwise go unnoticed. Think of it as finding a needle in a haystack, but instead of searching one strand at a time, you can examine the entire haystack in one go. But it's not just about speed. Quantum AI could also help us tackle problems that are currently beyond our reach. For instance, simulating the conditions of distant exoplanets or deciphering the chemistry of potential biosignatures is incredibly complex. Quantum systems could model these scenarios with unprecedented accuracy, giving us insights into where and how life might exist beyond our planet. It's like having a cosmic laboratory where we can test theories and hypotheses in ways that were previously impossible. The implications for astrobiology are profound. By combining the analytical power of AI with the computational might of quantum systems, we could accelerate discoveries that might otherwise take decades or even centuries. This isn't just about finding extraterrestrial life. It's about understanding the fundamental nature of life itself and how it might arise in different environments across the universe. Quantum AI could be the key to unlocking these mysteries, reshaping our approach to one of humanity's oldest and most profound questions: are we alone? One of the most daunting challenges in the search for extraterrestrial life is the sheer amount of cosmic noise that can lead to false positives. Think of it like trying to spot a single firefly in a storm of lightning flashes. Astronomers and astrobiologists often grapple with signals or phenomena that seem like evidence of life, but turn out to be natural processes or even technical glitches. This is where artificial intelligence steps in as a powerful ally. By analyzing vast datasets with incredible speed and precision, AI algorithms are designed to sift through the chaos, identifying patterns that might escape the human eye while filtering out misleading signals. But here's the critical question: how reliable is AI in this delicate balancing act? After all, even the most advanced systems aren't infallible. AI's effectiveness depends on the quality of the data it's trained on and the sophistication of its algorithms. If it's fed incomplete or biased information, it could misinterpret a natural phenomenon as a sign of life, or worse, overlook a genuine discovery. Mistakes in this field aren't just inconvenient. They could reshape our understanding of the universe or lead us down the wrong scientific path entirely. To put it into perspective, imagine AI as a cosmic detective. It's not just about finding clues, it's about knowing which ones to trust. The stakes are incredibly high, and the margin for error is slim. That's why scientists are constantly refining these systems, training them on diverse datasets and testing their accuracy against known scenarios. It's a continuous process of learning and adaptation, ensuring that AI becomes not just a tool, but a trusted partner in the search for life beyond Earth. So, what happens if AI does make a mistake? Well, that's where human expertise still plays a vital role. AI can narrow down the possibilities, but it's up to scientists to interpret the results, ask the right questions, and validate the findings. This collaboration between machine learning and human intuition is what makes the process both robust and resilient. It's not about replacing humans, it's about augmenting our capabilities to uncover truths that might otherwise remain hidden in the vast expanse of space. Citizen science has always been about making the search for extraterrestrial life a collective effort, inviting people from all walks of life to participate in something truly groundbreaking. Projects like SETI at home have harnessed the power of volunteers, using their computers to sift through massive amounts of data in search of signals that might hint at life beyond Earth. But as the volume of data grows exponentially, the role of AI is becoming indispensable. By automating complex data processing tasks, artificial intelligence is not just speeding up the analysis but also enhancing its precision, allowing these projects to achieve results that were once unimaginable. So, how exactly is AI reshaping citizen science? For starters, it's taking over the heavy lifting. Instead of relying solely on human volunteers to manually comb through data, AI algorithms can quickly identify patterns, filter out noise, and flag potential anomalies for further review. This means that the contributions of everyday people are now amplified, as AI handles the repetitive and time-consuming aspects. freeing up human volunteers to focus on more nuanced investigations. It's a partnership where both humans and machines bring their unique strengths to the table. Take the Breakthrough Listen project, for example. Here, AI is used to analyze radio signals from distant stars, distinguishing between natural cosmic phenomena and potential artificial signals with remarkable accuracy. By integrating AI into the process, citizen scientists can contribute to a more efficient and targeted search, increasing the likelihood of discovering something extraordinary. It's a perfect blend of human curiosity and machine efficiency, pushing the boundaries of what we can achieve together. AI is also democratizing the search for extraterrestrial life in new ways. With tools like machine learning models becoming more accessible, even amateur scientists can train algorithms to analyze data from their own backyard observatories or telescopes. This opens up opportunities for more people to get involved, regardless of their technical expertise. The result, a more diverse and inclusive approach to one of humanity's biggest questions. And let's not forget the power of collaboration. AI platforms can now connect volunteers from around the world, enabling them to share insights and work together in real time. This global network of citizen scientists powered by AI is creating a new era of discovery, one where the search for extraterrestrial life is not just a scientific endeavor but a shared human adventure. By combining the ingenuity of everyday people with the cutting-edge capabilities of AI, citizen science projects are becoming more effective, efficient, and exciting than ever before. It's a testament to how technology can empower us all to be part of something bigger, reminding us that the search for extraterrestrial life is not just the domain of scientists, it's a journey we can all take part in. So far, our search for extraterrestrial life has been laser-focused on finding carbon-based organisms' life as we know it. But what if life exists in forms we've never even considered? This is where artificial intelligence could truly revolutionize the field. Unlike traditional methods, AI isn't limited by human preconceptions. It can sift through vast datasets, looking for patterns and anomalies that might hint at life forms based on entirely different chemistry, like silicon-based organisms or even life that thrives in environments we'd consider inhospitable. Imagine a scenario where AI analyzes data from a distant exoplanet and detects strange chemical reactions or energy signatures that don't align with any known carbon-based processes. These could be clues to a form of life that doesn't rely on DNA, water, or even oxygen. The beauty of AI is its ability to think outside the box, or, in this case, outside the periodic table. It doesn't need to know what it's looking for to find something extraordinary. It just needs to recognize that something is out of the ordinary. The implications of such a discovery would be staggering. It would challenge our very definition of life and force us to rethink what's possible in the universe. And while human researchers might overlook these subtle signs, AI could flag them as potential breakthroughs, opening doors to discoveries we've never even dreamed of. The question isn't just whether AI can find life, it's whether it can help us recognize life in forms we've never imagined. When we think about space missions, the image of rockets launching into the void often comes to mind. But behind every launch lies an intricate web of planning and precision tasks that are increasingly being handed over to artificial intelligence. AI isn't just crunching numbers in the background, it's actively revolutionizing how we approach space exploration. One of the most critical areas where AI is making an impact is in trajectory optimization. Calculating the most efficient path through space isn't just about saving fuel, it's about maximizing the chances of success. Traditional methods rely on complex mathematical models and human expertise, but AI can process vast amounts of data in real time, identifying routes that might have been overlooked. This means faster travel times, reduced costs, and the ability to reach destinations that were once considered too risky or distant. But AI's role doesn't stop at plotting courses. It's also transforming how we manage resources during missions. Spacecraft operate in extreme environments where every ounce of fuel, every watt of power, and every drop of water counts. AI systems can monitor and adjust resource usage on the fly, ensuring that missions remain on track even when unexpected challenges arise. Imagine a scenario where a probe encounters a sudden malfunction. AI could reroute power or adjust its trajectory autonomously, keeping the mission alive without waiting for instructions from Earth. This level of autonomy is crucial when we consider the vast distances involved in space exploration. Communication delays between Earth and distant spacecraft can take minutes or even hours, making real-time decision-making impossible. By embedding AI into mission design, we're essentially giving spacecraft the ability to think for themselves, making split-second decisions that could mean the difference between success and failure. So, how does this tie into the search for extraterrestrial life? By optimizing missions and enabling exploration of farther and more challenging environments, AI opens doors to regions of space we've never been able to reach before. Whether it's analyzing data from distant exoplanets or navigating the icy moons of Jupiter and Saturn, AI enhances our ability to uncover clues that might point to life beyond Earth. The integration of AI into space mission planning isn't just a technological leap, it's a paradigm shift. It's about doing more with less, pushing the boundaries of what's possible, and bringing us closer to answering one of humanity's most profound questions: are we alone in the universe? As we continue to refine these systems, the future of space exploration looks not only more efficient but also far more promising. To truly uncover where extraterrestrial life might thrive, scientists rely on simulations that recreate the conditions of distant planets. But here's where artificial intelligence steps in to revolutionize the process. Unlike traditional methods, which can struggle with the complexity and unpredictability of alien environments, AI can analyze massive datasets, everything from atmospheric composition to geological formations, and predict outcomes with remarkable precision. This ability allows scientists to create more accurate models of worlds we've never even visited. Take, for example, the search for life on icy moons like Europa or Enceladus. AI can process data from spacecraft missions, combining it with our understanding of Earth's extreme environments, to simulate what life might look like beneath their frozen surfaces. These simulations don't just guess, they use patterns and probabilities to paint a clearer picture of what's possible. What's more, AI can adapt to new information in real time. As we gather more data from telescopes, rovers, or even future interstellar probes, these systems can refine their predictions, making the models increasingly precise. It's like having a constantly evolving map of the unknown, guiding us toward the most promising targets in our search for life. But the implications go even further. By simulating alien environments, AI also helps us prepare for the challenges of exploring these worlds. Whether it's predicting the behavior of a methane lake on Titan or modeling the radiation levels on Proxima Centauri b, these advancements could one day shape the way we design missions and even equip astronauts for the journey. In the end, AI isn't just a tool, it's a partner in our quest to understand the cosmos. By enhancing our ability to simulate alien environments, it brings us closer than ever to answering one of humanity's oldest questions: are we alone in the universe? What if the key to finding alien civilizations isn't just in their biology but in their technology? Technosignatures' evidence of advanced extraterrestrial engineering might hold the answers we've been searching for. Unlike biosignatures, which hint at life, technosignatures point to intelligence and innovation. And here's where artificial intelligence steps in as a game changer. AI's ability to sift through vast datasets, recognize patterns, and identify anomalies makes it uniquely suited to spotting these technological breadcrumbs scattered across the cosmos. Imagine AI scanning the night sky, not just for stars but for structures that defy natural explanation. One of the most iconic examples is the hypothetical Dyson sphere, a massive construction designed to harness a star's energy on an unimaginable scale. To the naked eye, a Dyson sphere might be indistinguishable from other cosmic phenomena, but AI, trained to detect irregularities in light patterns or energy emissions, could flag it as a potential sign of alien engineering. Similarly, AI could identify other megastructures or unusual energy signatures that hint at civilizations far beyond our own. But it's not just about spotting massive constructions. AI could also detect subtler technosignatures like unusual radio signals or laser communications. These signals, often drowned out by cosmic noise, could be the faint whispers of a distant civilization. With its ability to filter out interference and focus on specific frequencies, AI acts like a cosmic detective, piecing together clues that might otherwise go unnoticed. The question isn't just could AI detect these signs, it's how soon might it uncover something groundbreaking. The beauty of AI lies in its adaptability. As we uncover new possibilities for technosignatures, from interstellar probes to industrial pollution in exoplanet atmospheres, AI can evolve alongside our understanding. It's not just a tool, it's a dynamic partner in our quest to answer one of humanity's oldest questions. Are we alone in the universe? With AI on our side, the search for technosignatures becomes not just a possibility but a thrilling frontier of discovery. One of the most remarkable aspects of modern astrobiology is how it's bringing the world together. The search for extraterrestrial life isn't confined to one country or institution. It's a shared mission that spans continents. Artificial intelligence is emerging as a critical tool in this global effort, acting as a universal language that connects researchers across borders. Think about it, data collected from telescopes in Chile, probes sent to Mars, or underwater explorations in the Antarctic can now be analyzed by AI systems that speak the same analytical language. This standardization eliminates barriers, allowing scientists from different nations to collaborate more effectively than ever before. Take, for example, the way AI processes vast datasets from observatories around the globe. Instead of isolated teams sifting through mountains of information in silos, AI systems can integrate and analyze this data collectively. This not only speeds up discoveries but also ensures that insights are shared in real time, fostering a sense of unity in the scientific community. It's like having a global brain where every piece of knowledge contributes to a greater understanding of the cosmos. But AI's role goes beyond just data processing. It's also fostering innovation by enabling researchers to build on each other's work. A breakthrough in one lab can quickly inspire new experiments halfway across the world, all thanks to AI's ability to share and interpret complex findings. This collaborative spirit is essential in a field where the stakes are as high as answering one of humanity's oldest questions: are we alone in the universe? What's truly exciting is how AI is democratizing access to astrobiology. Smaller research teams and institutions in developing nations can now participate in this grand endeavor, leveraging AI tools that were once only available to well-funded organizations. This inclusivity not only broadens the pool of talent but also enriches the search with diverse perspectives and ideas. Imagine a future where the first confirmed discovery of extraterrestrial life is the result of a collective effort powered by AI and driven by scientists from every corner of the planet. It's a vision that underscores the importance of working together, and AI is the glue that makes it possible. By breaking down barriers and amplifying collaboration, artificial intelligence isn't just aiding the search for alien life. it's uniting humanity in the process. Imagine a future where AI-powered space probes glide silently through the far reaches of our solar system, analyzing alien landscapes and making real-time decisions without human intervention. As we look ahead, the intersection of artificial intelligence and astrobiology promises to redefine how we search for life beyond Earth. Autonomous systems equipped with self-learning algorithms could one day sift through vast amounts of data from distant planets, moons, and even exoplanets, identifying potential biosignatures with unmatched precision. These advancements might not just speed up the process, they could uncover patterns and anomalies that human researchers might overlook. One of the most exciting possibilities lies in the development of adaptive AI systems capable of evolving their search strategies based on new discoveries. For instance, an AI on a mission to Europa, one of Jupiter's icy moons, could analyze data from its subsurface ocean and decide in real time where to drill next or what chemical compounds to prioritize for further study. This level of autonomy could revolutionize our approach, turning slow, methodical exploration into a dynamic, responsive process. Beyond our solar system, AI could play a pivotal role in processing the immense volumes of data from next-generation telescopes like the James Webb Space Telescope. By identifying subtle atmospheric signals or unusual fluctuations in starlight, AI might help us pinpoint planets with conditions ripe for life, planets that would otherwise remain hidden in the cosmic haystack. Of course, this future isn't without its challenges. Developing AI systems that can operate reliably in the harsh, unpredictable environments of space is no small feat. And there's the question of interpretability. How do we ensure that the conclusions drawn by these algorithms align with scientific understanding? Still, the potential is undeniable. As AI continues to evolve, it could become not just a tool in the search for extraterrestrial life, but a partner, one that expands the boundaries of what we can discover and understand about the universe. Here's the next section of the script, crafted to align with your outline and guidelines. While artificial intelligence has the potential to revolutionize our search for extraterrestrial life, it's essential to consider the risks of placing too much trust in machines. After all, AI systems are only as good as the data they're trained on and the algorithms they follow. What happens if a crucial signal is misclassified or overlooked because the system wasn't designed to recognize it? Even the most advanced AI can make errors, and in the search for something as profound as extraterrestrial life, a single mistake could have massive consequences. Imagine a scenario where a faint, irregular signal from a distant star is dismissed as noise by an AI, when in reality, it could have been our first contact with another civilization. The stakes are simply too high to rely solely on machines. One of the biggest challenges is the inherent limitations of AI. These systems excel at processing vast amounts of data quickly, but they lack the intuition, creativity, and contextual understanding that human scientists bring to the table. For example, AI might struggle to interpret ambiguous signals or identify patterns that don't fit neatly into its training data. Humans, on the other hand, can approach these challenges with curiosity and adaptability, asking questions that machines might never consider. This is why a balanced approach, one that combines the efficiency of AI with the ingenuity of human researchers, is so critical. Over-reliance on AI could also lead to complacency. If we become too dependent on machines to do the heavy lifting, we risk losing the skills and expertise needed to interpret data and make decisions. Worse, we might stop questioning the results AI produces, assuming they're always correct. But history has shown us that even the most advanced technologies can fail, and blind trust in them can lead to costly mistakes. In the search for extraterrestrial life, where the answers could redefine our understanding of the universe, we can't afford to let machines take the wheel entirely. So how do we strike the right balance? The key lies in collaboration. AI can handle the tedious, time-consuming tasks, like sifting through terabytes of radio signals or analyzing planetary images, while human scientists focus on interpreting the results, asking the big questions, and exploring the anomalies that don't fit the expected patterns. This partnership allows us to harness the strengths of both worlds, minimizing the risks of over-reliance on either side. After all, the search for extraterrestrial life isn't just about finding answers, it's about asking the right questions, and that's something humans and machines can achieve together. What if the discovery of extraterrestrial life isn't made by a human mind but by a machine? This scenario isn't just a technological achievement, it's a philosophical earthquake. Imagine the moment when an artificial intelligence system, analyzing data from distant galaxies or ice-covered moons, detects signs of life. Suddenly, the age-old question, are we alone, is answered not by a human explorer but by a machine. This raises a cascade of profound questions about our place in the universe and the nature of discovery itself. For centuries, humanity has grappled with its significance in the cosmos. The search for extraterrestrial life has been deeply tied to our identity, our curiosity, our drive to explore, and our desire to understand our uniqueness. But if AI makes this discovery, what does that mean for our role as explorers and thinkers? Does it diminish the human spirit, or does it elevate our tools to a new level of importance? The very act of finding life beyond Earth could shift from a human endeavor to a collaboration between humans and machines, blurring the lines between creator and creation. And then there's the question of interpretation. Discovering life is one thing, but understanding its meaning is another. If AI identifies microbial organisms on Europa or detects biosignatures in an exoplanet's atmosphere, how do we, as humans, process that knowledge? Do we trust the machine's analysis, or do we need to verify it ourselves? This introduces a new layer of philosophical complexity, the interplay between artificial intelligence and human intuition. Can AI truly comprehend the significance of such a discovery, or is it merely a tool that expands the reach of human understanding? Beyond these questions lies an even deeper consideration. What does it say about us if we outsource the search for life to machines? On one hand, it's a testament to human ingenuity, our ability to create systems that can achieve what we cannot. On the other hand, it might reflect a shift in our priorities, where the pursuit of knowledge becomes less about human experience and more about efficiency and results. Is this a step forward or a step away from the essence of what it means to be human? These philosophical implications aren't just theoretical, they're deeply personal. They challenge us to rethink our relationship with technology, our role in the universe, and the meaning of discovery itself. If AI is the one to answer the question, are we alone? It doesn't just change our understanding of the cosmos, it changes our understanding of ourselves. The search for extraterrestrial life stands as one of humanity's most profound and enduring quests, a journey that has captivated our imagination for generations. Now, with the rapid advancements in artificial intelligence, we're on the brink of a new era in this cosmic exploration. AI is not just a tool, it's becoming a partner capable of sifting through vast amounts of data, identifying patterns invisible to the human eye, and potentially uncovering clues that could lead us to the discovery of life beyond Earth. From analyzing faint signals from distant stars to decoding complex patterns that might represent alien communication, AI is reshaping how we approach this monumental challenge. Yet, as we stand at this crossroads, it's important to recognize the challenges that lie ahead. While AI offers unparalleled speed and precision, it's not without limitations. Its ability to interpret data relies on the frameworks we provide, and there's always the risk of misinterpreting natural phenomena as signs of life. But even with these hurdles, the potential is undeniably thrilling. Imagine a scenario where AI deciphers a message from another civilization or identifies a biosignature on a distant exoplanet moments that could redefine our place in the universe. What makes this journey even more remarkable is the collaboration between human ingenuity and machine intelligence. Together, we're pushing the boundaries of what's possible, blending creativity with computational power in ways that were once the stuff of science fiction. As we continue to explore the cosmos, the bond between astrobiology and AI grows stronger, promising discoveries that could reshape our understanding of life itself. So, what do you think? Will AI be the first to uncover the secrets of extraterrestrial life? Could it be the key to answering one of humanity's oldest questions? Share your thoughts in the comments below, and don't forget to subscribe for more explorations into the cutting-edge intersection of technology, space, and the unknown. The cosmos is vast, and the possibilities are endless. Let's discover them together.